we're going to determine first of all whether it's a compound interest or present value question again. And so it says, Candy has won a lottery and wishes to set up education funds for her two children, Mike and Ike. If you know the Candy, you know what I'm talking about. How much should she invest today at 10% per annum, compounded semi-annually, in order to have $10,000 each for Mike in 7 years and Ike in 12 years? So, if we take a look at what information we're given, first of all, we want to know how long it'll take or how much she should invest today at 10% per annum, compounded semi-annually, in order to have $10,000 each for Mike in 7 years and Ike in 12 years. So this question actually has two parts to it. We want to know how much she should invest for Mike so that he has $10,000 in 7 years, and then how much she should invest for Ike so he has $10,000 in 12 years. Okay? So this $10,000 that you're given in this question is actually representative of the accumulated amount over time. Okay? The principal amount is how much she needs to invest right now, and if you look at the initial question, it says how much should she invest today at 10% per annum, etc., etc. Okay? So we're trying to figure out what the principal amounts should be. Okay? So we're trying to figure out the principal amount that she should invest for Mike, and then the principal amount that she should invest for Ike. Okay? So let's start with the compound interest formula, since we are told that we're looking at compounded interest. So A equals P times 1 plus I to the exponent n. And so if we look at Mike's situation first, so let's take a look at just Mike for now, and then we'll do the same thing for Ike. For Mike, we know that the accumulated amount is $10,000. We know the interest rate is 10%, so 0.10. And we're told that the interest is compounded semi-annually, so we're going to divide that by 2 because the interest is compounded twice a year. And so the interest rate at the end of each half of the year would be 0.05, or in other words, 5% per year. Okay, the number of compounding periods. So for Mike, she's investing for 7 years, and interest is being compounded semi-annually. So for Mike, it's twice a year for 7 years, so there's 14 compounding periods. So that's all the information we need to try to solve for the principal amount she needs to invest for Mike. So if I rearrange the equation so that I have P by itself first, I'm going to divide both sides by 1 plus I to the exponent n. And so I'll get an equation that isolates P on the right-hand side. And I'll substitute in the information that I know for A, I, and n on the left-hand side. So I have 10,000 divided by 1 plus 0.05, so 1.05, to the exponent 14, since that's the value of n. And if I evaluate that on the calculator, I get 10,000 divided by 1.05 to the exponent 14, and that gives me $5,050 and about 68 cents, approximately, is how much you should invest for Mike. Now, for Ike, she's going to be investing for a longer period of time. She's going to be investing for 12 years. So I'm actually going to expect that she's investing more money for Mike than she is for Ike. Okay, so let's take a look at Ike's situation. Okay, so for Ike, she's investing for an accumulated amount of $10,000, so that's how much money she wants to have in the future. And the interest rate is 10%, and it's being compounded semi-annually, so that hasn't changed, so that's still 0.05. And the number of compounding periods, now this is what's going to change. She's investing for 12 years for Ike, so twice a year, since it's compounded semi-annually. For 12 years gives me 24 compounding periods. So that's the only thing that's really changed. And so I'm going to look at the principal value equation, or the present value equation, so A over 1 plus I to the exponent n. And that's, I pretty much got that from when I isolated it in Mike's part of the equation. And so I get P equals 10,000 divided by 1 plus I, so 1.05 to the exponent 24. And I get P equals 10,000 divided by 1.05 to the exponent 24 and that gives me $3,100 and about 68 cents. Okay, so that's how much you should invest for Ike, and that's how much you should invest for Mike. And that makes sense because she's investing for a longer period of time for Ike and a much shorter period of time for Mike. So obviously for Ike, she should invest a smaller amount. Okay, so if you're trying to figure out how much she should invest in total, all you need to do is add up the two numbers to figure out how much money she needs to invest in total to have enough for both of her kids. And so the total amount invested should be $5,050.68 plus $3,100.68 to get a total of $8,151.36. So therefore, Candy should invest about $5,050.68 for Mike and $3,100.68 for Ike.